Welcome dear students. I am Dr. Divakar Mehta, Assistant Professor from Carmel College of Arts, Science and Commerce, NUM. The program you are learning is Bachelor of Science, first year, subject Botany, semester 2, course code BOC 102, course title Biodiversity 2, which includes vascular plants. Title of the unit Biometrics, Numerical Taxonomy and Cladistics. And the module name is Characters, Variations and OTUs. Broad outline of the module. First we will have introduction about biometrics, numerical taxonomy and cladistics. Then we will try to learn about characters, variations and OTUs. At the end of this module, you will be able to recall the terms biometrics, numerical taxonomy, characters, variations and OTUs. You will be also able to describe characters, variations and OTUs. So in day-to-day life, you might have heard or always you will be coming across the word biometrics. There will be biometric machine in the office, everywhere you will find. So these are the instruments which will be used to identify, that is based upon certain physical characteristics of human beings. And biometrics is a technical term for body measurements. In plant taxonomy, biometrics is the quantitative measurement of plant characters. In classical taxonomy, some of the plant descriptions are vague. You will find the description as leaves are long, flowers are small, flowers are large, petiole short or long. Like this, you will find these terms will not give you the definite length or any idea of the structures. Whereas modern taxonomy considers the actual measurement of these parameters. So you will find in the modern taxonomic literature, they will give the measurements, length of the leaves, breadth of the leaves, or flower diameter, fruit diameter, like that. They will give the measurements, actual measurements of the plant parts. Numerical taxonomy. Advances in microscopy, imaging, that is digital imaging, and computational analysis, these have resulted in increased variety and quantity of available data. And because of the availability of all these data, it has led to a new branch of biology that is called numerical taxonomy. Numerical taxonomy has many other alternative names, that is mathematical taxonomy, taxometrics, multivariate morphometrics and phonetics. Definition of numerical taxonomy. Numerical taxonomy can be defined as the numerical evaluation of affinity or similarity between taxonomic units and ordering of these units into taxa on the basis of their affinities. Numerical taxonomy does not produce new data or new system of classification. What it will do, it will try to give or it will try to organize data in such a way that it will help us to understand in a better way what is the relationship between different taxa. In contrast to most of other old classification system, numerical taxonomy seeks to base classification on a greater number of characters from many set of data. For example, Bentham and Hooker's system of classification or older system of classification, if you consider, they will consider few morphological characters, whether ovary is superior or inferior, petals are free or fused. Like that, we will see very few characters, morphological characters are considered for classification. Whereas here in numerical taxonomy, a huge number of data will be considered for the classification of these plants. Now we will try to learn about characters. A character is a characteristic that distinguishes one taxon from another. In numerical taxonomy, A character is a feature which will vary from one organism to another. For example, flower color. A plant may have red flower, another will have yellow flower, another may be white, blue, like that you will find different types of flower color. So that is a character. Same way trichome type. Trichome may be glandular, aglandular, habit. A plant may be woody or herbaceous, etc. you will find. So these are called characters. Characters are of two types: binary characters and multi-state characters. Binary characters are the characters which will exist in two states. For example, trichome. Trichome can occur as glandular or aglandular. Habit of the plant. It may be woody or it may be herbaceous. Multi-state characters. Characters which exist in more than two states. They are again of two types: qualitative multi-state characters and quantitative multi-state characters. For qualitative multi-state characters, flower color, you will find different types of color, not only two types of color as it. Okay, so we will consider them as qualitative multi-state character. But you will not find the quantity here. It is just color of the flower. Then quantitative multi-state characters, leaf length. What is the length of the leaf? What is the diameter of the fruit? What is the height of the plants? All such things comes under quantitative multi-state characters. When you get all the characters, handling of characters is very important. So what we have to do? We have to list all the characters which you come across or which you have observed. Every character we have to list them. And there should not be less than 60 characters for numerical taxonomy. More than 80 characters will be desirable. So always you should have at least 60 characters for any kind of numerical taxonomy. Now we will try to learn about variations. We have learnt about characters. Now come to variations. A species is not static. Even if you take two individuals of a species also, they are variable. At least some characters will be different from each other. So you will find always there will be variation in characters. For example, flower color. It may be white, it may be red, blue, yellow, etc. We find variation in habit, habitat, pollen, features, venation type. Also we will find different variation. These are some list of characters and their variations. Leaf incision. You may find simple leaf, compound leaf, carpels may be united, free, like that. These are some of the characters you can go through. Venation, habit, habitat, pollen, phyllotaxy. All these are some of the characters and its variation in the characteristics. Now come to OTUs. OTUs are nothing but operational taxonomic units. And operational taxonomic unit is the basic unit in numerical taxonomy. It is a term used with reference to a group of closely related individuals under consideration for classification. These OTUs would be class, family, genera, species, population, etc. In numerical taxonomy, OTUs of equal ranks are used to compare. We can't compare a class and a family like that. Always you have to consider equal ranks. For example, for the comparison of a species, we have to consider different population of that species. Same way for a genera, different species, and for a family, different genera will be considered for comparison under numerical taxonomy. It is not advisable to use genera and higher ranks as OTUs, because when you consider the higher order, there will be lot of difference between the individuals or taxonomic units. So then you may not get a good result. Once OTUs are selected, a list of such OTUs is to be prepared. So in this module, we have learnt about biometrics, numerical taxonomy, characters, variations, and operational taxonomic units. These are the references. Thank you.